Okay, so when we're talking about data, we either have categorical data or numerical data. If we have categorical data, then we're going to display that data using a bar chart or a pie chart. When we go to talk about categorical data, we're going to talk about the most frequent category, the least frequent category, and anything else you think might be interesting about the graph. If you have two categorical data, you might be able to use the graph to talk about independence or association. If you have numerical data, either discrete numerical data, which is a count, or continuous numerical data, which are measurements, you can make a dot plot, a stem plot, or a histogram. When you talk about numerical data, you're going to talk about the socks in context, which means you're going to talk about the shape, any outliers, what the center is, mean or median, and what the spread is, which could be range in this first chapter, or it could be interquartile range or standard deviation in future chapters. The other thing is, how do we decide which sort of graph to make? Dot plots and stem plots are both good for nice small data sets. You start to get a few more numbers, you might go towards the stem plot instead. But a histogram is what you're going to use for large data sets. In general, we do not make a dot plot or a stem plot for a large amount of data. Now, to construct a histogram, there are a couple of things that could happen. Okay, when we're talking about discrete numerical data, the bars in a histogram, first off, always touch. So I have this data here, and it says promiscuous raccoons. The data below gives the number of mating partners for a group of promiscuous raccoons. Okay, and we want to see, we have 1 and 3 and 2. We've collected this data. So the first thing that you're going to do is that you're going to measure the number of partners, and you're going to go, I see the smallest number, just like we did in our stem plots and in our histograms. I look for my smallest number, which is 1. I look for my largest number, that was 4. And in this case, because this is discrete counts, we can put the number from 1 to 4. Okay, the next thing that we're going to do is we're going to physically count how many there are and count that frequency value. So I'm going to go through and note 1, 2, 3, 4, 5, 6. I've got 1, 1, 1, and it turns out we have 18 ones, we have 5 twos, we have 3 threes, we have 3 fours. That gives us 29 total values in this data set, of which we could find the relative frequency. Remember to find relative frequency, that's going to give us our percentage. So we've got 18 out of 29. That's where we're getting that 0.621. So in order to make a histogram of this data, what we're going to do is on the horizontal scale, we're going to mark with the possible values of the variable. Now, since this is discrete data and we literally just have counts 1, 2, 3, 4, we're going to center the bar around that value. On the vertical scale, we're going to mark this with either frequency or relative frequency, but we will never, ever, ever break that vertical axis to make it easier for us. We're always going to show it all the way from 0 scaled up to where it needs to be. And then we would draw that bar. Okay, so notice over here, this is the same graph, one where I've measured frequency on the vertical axis, one where we have relative frequency on the vertical axis. Notice that the number, the bars do touch, unlike a categorical bar graph. 1, 2, 3, 4, bars do touch. Number of partners, that's the variable. We're going to label that. And then we've either got frequency or relative frequency. Okay, and so you can see the bars are just sort of measured there. If I was going to talk about this, I would kind of go through those socks. Okay, for the shape here, this graph looks like it is skewed to the right. Okay, skewed to the right. I do not see any outliers, so I wouldn't comment on that. And for center, we could probably find our median here pretty easily. There are 29 values, which means that the median would be the 15th number, 14 on the left, 14 on the right, and 1 in the middle. Since I look, there are 18 values in that first bar. I know that the median value is going to be in that first bar. So the median is going to be 1 partner here. As far as the range goes, okay, we're going to do 4 minus 1, and that's going to give us 3, a range of 3. And if we look at this, if we were going to talk about something, what is this graph actually telling us? We would probably say it looks like raccoons are, for the most part, monogamous with 1 mating partner here, okay? Now, if we were in class, we'd be doing this roll the dice activity, but we're not going to do that today. Now, if you turn in your notes to the next page, if you have grouped data, what you might see instead is something like this. we would have our bars, and they would be grouped according to lots and lots of values. For example, let's say you could have a score from 200 to 249, 250 to 299. There's a couple of ways you could do this. The first thing you could do is you could split the difference in between 249 and 250, and you could label this little spot right here 249.5. A lot of times what actually happens, though, is that we would label this 200 and then 250, and this would be 300, etc. And the way that this is generally read is that it is an open circle. Sorry, I said this backwards. Okay. It is a closed circle leading up to an open circle sometimes, or it might be the other direction. So in this case, I would read this as 200 is included, and it goes all the way up to 250, but it doesn't actually include 250. Sometimes in the context, it may be the other way around. We may include the right side, but not include the left side. So you may have to give instructions on how to read that. If you wanted to not have that issue, again, you could split this bar and say it goes up to 249.5. And you wouldn't have that issue. So across the bottom, you would label these as every other one. You can see our frequency or relative frequency up here on this vertical axis, and you would scale that. So, this looks like this is 2%, 2% and 4%. And 6%. And so again, what you would do is you would tally how many values you actually have in those ranges. Remember that the vertical axis should never be broken, and that you can end these in between the upper and lower class to make that useful. Okay, so I can say this is 249.5, this is 259.5. That would be one way of grouping this value. Sometimes you, again, may see this as this particular value is up to 450 maybe, as opposed to having it closed circled in there. Okay, if I was going to talk about this histogram, I'd probably label this as roughly symmetric. Okay, now if we want to make our class interval widths equal as possible, so the following data represents the students enrolled in public universities in each state. So we have to decide how we would split this up. So I would scroll through here. I'm trying to find my biggest number and my smallest number. That's usually where I want to try to find this. So, smallest number, biggest number. Let's see, here's a 93. Do we have anything bigger than 93? Here's a 96. I don't see anything bigger than 96 in this case. Smallest number, here's a 46.2. Do I have anything smaller than 46.2? And I would try to decide how I'm going to range this. So you do have options. Unless you're told specifically how to make it, you just need to make sure, that your class interval width is the same. So for example, we could use 7 intervals that were 8 units wide: 44, 45, 46, 47, 48, 49, 50, 51. That would be the numbers from 44 to 51. That's 8 units. And then we could go 52, 53, 54, 55, 56, 57, 58, 59. So that one would go from 52 up to 59. So basically, when you would go to make these bars across the bottom of your number line, you would say 44 and 52 and 60. Okay, those would be your across the bar. And you'd have one bar that goes from 44 to 52, one bar that goes from 52 to 60. And what you just need to understand is that that bottom level is included, but that top level is not. So to figure out how many you have in each space, you would set these up, and then you would do a tally. And you would say, okay, I've got 86, that would go here, and 96, that goes here. And once you have that tally made, then you know how tall to draw the bar. Now, that's great, and that's fine. But you could also, in this case, instead of going and creating some sort of range that works like this, you could just do something easy, like an interval of width 10 from 40 to 50, 50 to 60. So you have a lot of freedom of how you do this. But once you have these set up, again, you're going to go through and you do your tally and say, okay, I've got, here's 66 and here's 86, and go through and tally how many you have in each spot. That's going to give you that frequency. Once you have that frequency, you know how to scale and draw that vertical bar. All right. One of the things you need to be able to do is to talk about the comparisons in a histogram. In this case, if I was going to talk about the similarities and differences in these two histograms, this is set A and this is set B. And there's one like this on the homework. I think it's comparing males and females. One thing I want you to notice is that they're going to share the same set of scale across both axes. Okay, so they should be stacked vertically on top of each other, and they should keep that same scale. So if I wanted to compare these, what I would want to do is I would want to go through this and say, okay, where about my shape? And I think both of these look roughly symmetric. Okay, so they're not perfectly, but both of these do look approximately symmetric and unimodal. Okay, so I've got approximate symmetry here. As far as any outliers, I don't see any outliers with either group. When I see the center, I just kind of estimate this here. Okay. Oh, actually, I don't have to because it says it right here. This up here, it says mean. Oh, great. We can use the mean as the center. Okay. So as for the center, it looks like, and I can see this visually and because they told me, it looks like distribution A has a higher mean. Okay, and that higher mean is 26.3 than distribution B has, which is only 5.62. So on average, those numbers are higher. And as far as the spread goes, let's just talk about range. It looks like it goes from about 48 down to about -6. Okay, so 48 to about -6. What is that? 48 down to, oh no, well, maybe -6. That's actually 0, isn't it? What am I doing? So from 0 up to 48, that's going to be 48 units. Woo! And then down here from 30 down to -18, that's also going to be 48 units. So that would have the same spread at about 48 units. So if I was going to write this in a complete paragraph, which I really should, I would say for the distributions of variable name, the variable is not labeled here, which is a big no-no. But if it was height or width or number of pencils you have in your backpack, I would mention that. The distributions of number of pencils in your backpack are approximately symmetric. The distribution A has a higher mean of 26.3 units than B at 5.62 units. Also, they have the same range of about 48 units. Okay. Now, when we are talking about histograms, it's important to remember that we deal with populations and samples. So when we have a population histogram here, here's the population. This is everything. If we were looking at this, we would say that looks skewed to the right. One thing you'll notice with the sample histograms, so these are just random samples that are drawn from this data. You're going to notice that these also sort of have that skewed right shape. However, it's not quite as intense as the original population. Okay, so even though the histograms look different, they do seem to have roughly the same shape. And this is something that you might see happen. For example, if you have a population that's bimodal, it's not uncommon to have a sample drawn from that also looks bimodal. Or if you have a population that's symmetric, it's not uncommon to have your sample look symmetric. You'll also notice that the centers are about the same. If I had to guess where this mean was, I would guess probably around 2 to 3 is kind of a balance point, about a 50. Oh, I guess I could figure it out. These are percentages, right? So the median would be at 50%. Here is 15%, a little bit more than 15. Here's about 23. All right, so if I look at that, we're talking at about 38%. In order to get to the 50th mark, I would want to be in that 2 range. So this definitely has a median of 2. If you look at the rest of these and ask is 2 about where that 50th percent is, you're getting pretty close all the way across. So they also seem to have a very similar median value. As far as outliers go, none of these seem to have any outliers. And then when we go to talk about spread, here's where things get a little interesting. So even though the population histogram has the same shape as its samples that were drawn from there, so they all look skewed to the right, and even though the centers are about the same, the range is not the same. The original has a range of about 11, whereas this guy's range looks about 7, this one looks about 8, this one looks about 9, and this one looks about 10. All right, so this is an important thing that's going to be really, really, really important in our next chapter. when we're taking and drawing samples from populations, in general, the sample distribution will often have a similar shape to the population distribution. The sample distribution will often have a similar mean or median to the population distribution. However, the sample distribution will almost always have a smaller range than the population distribution. So samples do a really good job of estimating the overall shape of the population, and samples do a really good job of estimating center, but they do a terrible job of estimating spread. Sample is almost always going to have a smaller spread than its population does. Okay, it's almost always underestimated. Part of that is because in order to have the full range, you've got to have the maximum and minimum value, and there's just a chance of that not being selected in the actual sample itself. Okay, now I'm going to make a separate video on how to practice and do a histogram in the TI Inspire. So I'm just going to switch this for right now. But if we were going to do this in person, like by hand, I have these 89 values. If you were going to make a histogram for this, one thing you might do is go through and find the smallest and largest value here. And it looks like my smallest value may be 6. And it looks like my largest value, let's see, I see a 34. Do I see anything higher than 34? Looks like 34. So maybe one thing I could do is I could go over here and I could label, and I'm just going to break this axis so I don't have to stick this over here. Okay, and I'm going to label this 0, and I'm just going to go by 5s. 5, 10, 15, 20, 25, 26, 30, got carried away, 30, 35, okay? And I'm going to label this is 89, have the following time in months to the first malfunction. All right, so this is months. And then the second thing I'm going to do is I'm going to go through and figure out how many I have of each of these. Okay, now I've done a little work ahead of time. You would probably want to do this tally chart thing off to the side. Okay, and I'm going to go ahead and label this as I've got 8 and 16 and 24 and 32. So those are my frequencies. I'm going by 8s here when I'm counting. And what I would do is I would go through and tally and say, how many numbers do I have between 0 and 5? Because when I thought this was 6, so maybe I've got a mistake here looking at my notes. How many numbers? Up here's a 2. There's 1. What else do I have here? I'm looking for 0s to 5. Here's another 2. All right, I've got 2 of those, so I'm going to go and label that. There are 2 of those. And now I'm going to count and see how many numbers I have from 5 to 10. All right, 5 to 10, I've got 1. And this 10, remember, that goes in that next group. So really, I'm looking 5 to 9. I've got 1, 2, 3, 4, 5, and 6. I've got 6 of those. So this bar is going to touch, and it's going to go up to 6. Okay, and then I'm going to look and see, well, how many do I have that are between 10 and 15 where the 10's included but the 15 is not? Okay, so basically 10 up to 14 there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Oh, and did I miss one? Maybe. All right, I think I got them all. All right, so that looks like 16 or 17 of those. Okay, so I'm going to draw that bar, and they're going to touch. And you would continue with this all the way across drawing these bars. If you continue with this, you're going to find that there are 18 in the next category. Okay, and there are 32 in the category after that. Well, that's a terrible bar. There are 8 in the 20 to 30s and there are no 35 to 40s. There's 6 in this one. All right. So these are the numbers I have on my little sketch of going through and counting how many are in each category. So again, you would do the same. How many do I have in each of these categories? Okay. And remember that when I say 0 to 5, I'm including the 0, but I'm not including that 5. So that 5 will jump up into that next one. So that's kind of how you would draw your histogram, hopefully with a little bit more care than my little sketch right here. Okay. All right. And we'll go how to do this in the TI Inspire here in a separate video. All right, that brings us to this last thing, which is something called a cumulative relative frequency plot, or something called an ogive. All right, so an ogive, it deals with what's called cumulative relative frequency or percentage. The idea is that I'm thinking about how many are up to this point. So if I look at my little histogram right here, when I get to 5, there are 2 that are up to 5. But then when I get to 10, I've got 8 that are up to and including or up to 10. And I've got, I keep going up. How many do I have up to this point? How many do I have up to this point? So we're going to use this with something about percentiles. So the percentile is the percent of individuals that are at or below a certain value. And the specific percentiles that we use a lot in here are quartiles. Quartiles would be located every 25% of the data. The first quartile is like the first quarter, 25%. The second quartile is the 50th percentile, and the third quartile is the 75th percentile. All right, so when I'm looking over here at this particular picture, what this is saying, I've got age over here, and notice that the very last spot goes, and if I look over, that is 1. This is called cumulative relative frequency. When I look at this spot right here, this is like 60, I don't know, like 65. What this is saying is that, and I look over, that looks like about 90%. This is saying that 90% of the people were 65 or younger. When I look at this little spot right here where 10 is, okay, and I look over, that looks like about 10%. That's saying that 10% of the people were 10 or younger. Okay, so to look at the quartiles, if I look for 25%, here's 30, so 25% is about right there. And I look down. Okay, so quartile 1, the 25th percentile, is about age 20. So what this is saying is, of the people we surveyed, about 25% of the people were age 20 or younger. Okay, 25% of the people were 20 or younger in this case. Okay, for the 50th percentile, look over, I'm going to kind of have to estimate that. I'm going to call that 32. All right, so the 50th percentile, which is also called the median, that's the spot right in the middle. 50th percentile looks like it's about 32 years. Okay, so the way I'm reading this is saying that 50% of the people are 32 or younger. 32 or younger. Okay. When I look for the 75th, here's 70, so 75 is up here. That looks a lot like that dot. That looks like about 45. My quartile 3 looks like it's about 45 years old. Okay. There's also this idea of interquartile range, which we're going to be talking about in our next chapter quite a bit. Interquartile range is the middle 50% of the data. In our case, that would be the difference between age 45 and age 20, which is about 25. That's saying that the middle 50% of our data is about 25 years long. Okay, from the quartile 1 to quartile 3, that middle 50%. Okay, so the percentiles are the percentage at or below a certain value. A quartile is specifically 25th, 50, and 75%. So I look at this ogive, this cumulative relative frequency plot, and I have some questions. So notice it says cumulative relative frequency as opposed to relative frequency. So this reads the percentage up to this point. Okay, what percentage of fatalities occurred for people under age 55? So I'm going to find age 55. I'm going to look up, boop. I'm going to kind of look over, boop. Okay, and let's see, maybe a little bit more than 80, maybe 85% here. Okay, so I'm going to answer that, 85%. Okay, so where this measures on the line is saying that I think there's 85% there that's 55 or below, which also means that if there's 85% are below this point, that must mean that 15% are older than age 55 as well. So another way to think about that, people 55 and under, okay, that reads as 85% on the graph, which means 55 and older is that 15%, is that remainder of that 100%. At what age do the youngest 30% of fatalities occur? All right, so the first 30% of fatalities, so I'm going to find this 30% here, and that looks like about age 20. So people ages 20 years and younger, 20 years and younger, that would be the youngest 30%. If I wanted to find the oldest 30%, I would work backwards. The oldest 30%, if there are 30% older, then that means there are 70% younger. So I might go over here and find that 70% mark and then look down and say the oldest 30%, okay, that oldest 30%, that's the 70th percentile, because if there's 70% at or below, there's 30% above, and that looks like that may be about 45 years old and up, okay? All right, so I have a little example here, and it wants us to make a cumulative relative frequency plot. Now, for sake of time in the video, here's how this would work. Okay, I'm going to go through, and I've got my classes already organized. Notice 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. These are all 10 units wide. Okay, 10 units wide. And then I would go through and I would do a little tally chart to get my frequency. Like here's a 40, tally mark. Here's a 26, tally mark. I need to see how many there are in those. Okay, I've already done that. If you go through and check, there are 6 and 9 and 13, 12, 4 in that case. And that gives me a grand total of 44 values here. 44 values. Okay, to find my relative frequency, remember I would take the 6 and I would divide by the 44. That gives me that relative frequency. In this case, I've already done this. This is going to be 14%. 9 out of 44 is 20%. 13 out of 44 gives me 30%. 12 out of 44 is about 27%. And 4 out of 44 is about 9%. All right, so here's how these cumulative frequency and cumulative relative frequency work. For cumulative frequency, I would take my frequencies and I'm going to progressively add them up. Okay, so for example, this first one is 6 here. Okay, and I would say 6, and I'm going to put this over here, 6. Okay, and now I'm going to add the next number. If there's 6 there, 6 plus 9 gives me 15. Okay, and then I'm going to add the next number. So up to this point, there are 6 plus 9 plus 13, which is 28. And then I'm going to add the next one. That's going to give me, oh, it didn't highlight, it scribbled over. That's going to give me another 12. 6 plus 9 plus 13 plus 12, that gives me 40. And then an additional 4 gives me 44. I can do the same thing with my relative frequencies. I'm just going to add them down. So at first I get 14%. Okay, I go one more. Okay, 14 and 20, up to this point, you've got 34%. 14 and 20 and 30, up to this point, you have 64%. 14, 20, 30, and 27, up to this point, you have 91%. And then adding in that other 9% gives you a 100%. Okay, so the question says, construct a cumulative relative frequency chart. All right, so I'm going to start, and when we do this, we are using up to this point. So we're going to be using these upper boundaries because we're saying up to 20, I have a certain percentage. So at 20, our cumulative frequency was 14%, which is about right here. Okay, at 30, we have about 34%. So that's going to be about right there. At 40, we had up to 40, had about 64%. At 50, we had about 91%. And then 60 is our highest value. That's going to score us at 90 or at 100%. And then I'm just going to connect the dots here, okay, and make this line. And then this one, I'm going to draw back to 0. Okay. So the first question says, what DRP score, which is this value down here, is at the 20th percentile? So I'm going to look over, and I'm going to measure that at about 24. What is the median DRP score? So again, I'm going to look for the 50th percentile. 50th percentile, to me, that looks like we're floating at about 35 or 36 there. What about the interquartile range? To get the interquartile range, I need the 25th percentile and the 75th. So interquartile range is the 75th minus the 25th. So I'm going to go find 75th first. I think 75th is looking somewhere in the neighborhood of maybe 43. Okay, so I go across 75th here. Where would 75th be? Okay, I look down, maybe about 43. Quartile 1, we're talking about 25th. That's going to be a little higher than I was before. How about maybe 27? Okay, I'm going to subtract those two values, and that gives me 16. Okay, so that's my interquartile range. It says a score of 40 is approximately what percentile? In this case, I don't have to guess. I can look up. Score of 40 is actually one of my dots. That is going to be, that says 0.64 up here on my table. So that is the 64th percentile. So our percentile is the percentage at or below a certain value. Okay, so that's 64th percentile. Now I know this video is kind of rushed. Okay, I plan on doing an example of how to do the histogram in the TI Inspire, and also maybe a better one of how to do by hand. But in the meantime, good luck. If you have any questions, let me know.